All right, so we were taking a look at the phrase velocity and talking about the fact that that was the first derivative, and acceleration we hadn't seen before. However, I think some of you have seen that word acceleration before in other calculus that you have taken. So do you remember what acceleration means? Yeah, it's second derivative. So when you're asked to find something about acceleration, it's talking about finding a second derivative. So we are asked on this problem to find a first derivative and a second derivative. That's all it's asking us to find. Okay? And they're asking us to find it for a position equation s of t equals 4t squared minus t plus 3 over the square root of t. And again, this looks like division, and we don't have any rule for what to do with division yet. So there must be some sort of way that I can simplify this with algebra that does allow me to do this problem. Any thoughts on that?
Read the top and distribute.
You could, and you don't even have to do it that way, though. Instead of bringing it to the top to distribute, I'm just going to distribute it where it is. And I'll write the square root of t as t to the 1/2. Now, that's a property of fractions. You usually use that property the other direction, right? You try to get a common denominator and you combine the numerators together. Well, because I have a single value in the denominator as the denominator, I can do it in reverse, and I can separate each of the individual numerator pieces out with that same denominator. You guys know what I'm talking about? Okay, so I have 4t squared over t to the 1/2, t over t to the 1/2, and 3 over t to the 1/2. So before I ever get started taking any derivatives, what I'm going to do is I'm going to simplify each of those to being a single expression. So for instance, that 4t squared over t to the 1/2, what can I do with those exponents? You subtract them. It's a property of exponents that says that when I have the same base, t, in the numerator and t in the denominator, I can subtract the exponents. So this is 4t to the 3/2. Okay, so I'm not doing any calculus yet. All this is algebra. Second thing, then, I've got t over t to the 1/2, so that's like t to the 1 over t to the 1/2. So if I subtract those exponents, what do I get? T to the 1/2, right. Now, in the last piece over there, I've got 3 over t to the 1/2. Well, that doesn't have anything to reduce with the t, so I'm going to do exactly what you'd suggested before, which is to bring the t to the 1/2 up to the numerator, which makes it t to the what power? Negative 1/2. And we saw a problem before on this one, this lesson, that did something similar, but with just plain old x. This form actually allows me to take a derivative now. Agreed? All right, fabulous. So we're going to find s prime now of t. So then, what is 4t to the 3/2 derivative? 6. I think you've got, well, I'll write it as 12 over 2 for the moment. You're right, it is 6. So if you take the 3/2 times the 4, you get 12/2, which we'll simplify, I recognize, to 6. How about the t to the 1/2? What do we get? T to the, good, 1/2 t to the negative 1/2. How about 3t to the negative 1/2? We're going to get a minus, right? Right. Negative 3/2 t to the negative 3/2. Excellent. I'll just do the one step, and I'll just do it right here, since I wrote it earlier, and we'll make that 12/2 of 6, like you mentioned. I'm going to leave just a little bit of space where I'm going to be able to rewrite the piece that this simplifies to here in a minute. But I need to take a second derivative as well, and I don't really want to simplify anything further before I take the derivative. I want it to be in this fractional, ugly-looking kind of form because it's easier to take a derivative of. So what is the derivative of 6t to the 1/2? Right, so 6 multiplies by 1/2 to give me 3, and the t then becomes to the negative 1/2. How about the negative 1/2 t to the negative 1/2? First it's a positive.
Negative.
Positive, right?
Positive 1/4.
Uh-huh.
T to the negative 3 halves.
Right. Positive 1/4 t to the negative 3/2. Then what? Positive 9/4, good. T to the negative 5/2, right. Good. So I'm going to put this back into positive exponents and radicals because that's how the problem started. So I'm going to come back up here where I skipped the space to rewrite this. This would be 6 square root t, because that's t to the 1/2, minus 1/2 square root t. So the t to the 1/2 goes into negative 1/2 goes into the denominator to be positive, and then a 1/2 is a positive or is a square root. And then the last one would be 3/2 square root of t cubed. And likewise, if you wanted to change that, you could write that t square root t. But this would be my derivative.
So you're saying we could write it as 2 square root of t cubed?
Yeah, like right here, what this would look like, if you wanted to write this differently, it would be 2t to the square root of times square root t. Because t to the 3/2 is 1.5. So there's 1 on the outside with a half still underneath
I
the
read
radical.
it as like square root of t and parentheses all to the third power. Is that the same?
It's the same thing.
I'm a bit confused
Yeah.
with the second one.
What's that?
I'm a bit confused with the second one. What is
The one in purple?
No, whenever you had the negative 1/2.
This one right here?
Yeah. How you got to that?
Okay, so the negative puts it into the denominator.
Okay.
Okay, so now I've got in the denominator t to the 1/2. And a 1/2 power is a square root. It's the same thing. It's the same reason that this 1/2 became square root t.
Right.
It's just that it's doing it in the denominator because it's negative.
I'm just wondering where the coefficient of the 1/2 was.
The 2 is still there.
It's still. Okay.
Yeah, 2 is just in the denominator because we've got denominators multiplied, so I just put them into, I combined them.
I was getting confused because I was thinking the negative 1/2 the 2 came from that.
No. It didn't. The 2 came from, or the negative 1/2 exponent turned into the square root. And if you might remember, not that it's a big deal, but you might remember that the reason that this 2 is, it's actually right there. It's the understood index of the problem, but square roots are common enough that we don't write them. It's kind of like writing a coefficient of 1 when we're just talking about x. We don't write 1x, we just write x. Same thing, we don't write square root, we just write the square root notation without the 2. All right, we have one more to do, this one here at the bottom to simplify, or at least to rewrite in a different form. So my second derivative here, I'd have 3 over the square root of t, right? And I'd have plus, I'd have 1 over, and then there's that 4. What would t to the 3/2 look like, negative 3/2 look like? Yeah, you can do the square root of t cubed, and this one is actually what I think you asked me before. Could I put the 3 out here like this? Which I could. That'd be the same notation. I tend to keep the cubing kind of closely associated with the t. It doesn't make any difference, so it's the same fact. Or again, you could write that as t square root of t. And then the last piece over here is the 9 over the 4. And then we'd have the square root of t to the 5th. Or t squared square root t, if you wanted to simplify the radical form. I'm not going to require you to simplify the radical form. This is plenty enough algebra to make me smile. Any questions on this one? Okay, we're going to do the next problem, take it one step further. This problem says that we're going to find the equation of the tangent line. So let's pause for a moment to remember what that means. We need an equation of a line. So what does the equation of a line look like? There's a couple forms. Not x squared line. Yeah, there was another form we used. Yeah, and when we did the equation of a tangent line before, that second one was the one we used. It's just a real nice form for us to use for this, which is handy. the x1 and the y1 can be found by using whatever the value is they give you. So here's x1, right? X is 4. And if I want to find out what y is that goes along with that, what would I do? You'd plug it in. So let's just do that here at first. So if I find f of 4, that would mean finding 2 x to the 3 halves, so that's 4 to the 3 halves, minus 3 times 4 to the negative 1/2. This is a good place for us to actually use that simplification from like the problem before. This actually means 2 square root of 4 cubed minus 3, and because it's negative, it's in the denominator, 3 over the square root of 4. What is the square root of 4 cubed? Square root of 4 is 2, and then cubed is 8. And then 8 times the 2 in front gives me 16. And you're welcome to use your calculator to verify the steps that you're doing sort of mentally. And then the other piece is 3 over the square root of 4, which is 3 over 2. Now, if you simplify this, what would that become? $25? I don't think it can become a whole number. Over 2, like this. $29 over 2. I'm hearing 2 answers. Which one do you think? Is it 29? Okay, so here's how I was thinking about it, just to give you some perspective. This is 16 minus 1 1/2, right?
Yeah, it's 20.
So this would actually give me 14 1/2. And then 14 1/2 would be the 29 over 2. There's lots of ways to think about it, but that would be one way to do it. So I've got 29 over 2. Excellent. So now I have found y1. I was given x1. What else do we need to find? The slope. How do we find the slope of a tangent line? That's the derivative. So this m is found by finding the derivative. And we now have a nicer way to find derivatives than we had when we did this the last time. So what is the derivative of this equation? All right, so what's the derivative of 2x to the 3 halves? 3x to the 1/2. So we're going to multiply the 2 at the beginning times 3 halves, which gives me 2. And then I've got x to the 1/2. And then I've got this minus sign right now, but it's minus 3 or negative 3 times negative 1/2, which gives me positive, what? 3 over 2. And then x to the what? Negative 3 halves. Now, you can put this back in the denominator and all of that. In fact, it's going to be helpful for us to do that simply because we're going to have to evaluate, right? Now, if I were just doing this problem, I could stop here because take a look at my original equation that I'm given. It does not have square roots in it, right? It doesn't even have positive exponents. So if I were just told find the derivative, there'd be no reason to simplify this or change the way this looks. Okay? But I'm asked to use this to actually evaluate it at the point x equal 4. So I'm going to find it helpful to write this as 3 square roots of x plus 3 over 2 square root of x cubed. Again, not because I need it for the sake of actually writing the answer in terms of that, but because it's helpful to evaluate. So now I need to evaluate this at 4 to find my slope. So I have 3 square roots of 4 plus 3 over 2 square root of 4 cubed. Let's do one piece at a time. What is the 3 square roots of 4 at the beginning? 6. What is the 3 over 2 square root of 4 to the third? 3 over 16. And can someone find the expression for that as an improper fraction? 99 over 16. Somebody's pretty decent at fractions. That sounds right. You guys know how to change that if you needed to, right? You'd write the 6 as 6 times 16 over 16. All right, so my slope is 99 over 16. My y value is 29 over 2, and my x value is 4. So I have y minus 29 over 2 equals m, which is 99 over 16 times x minus 4. Does that look okay? And then what are we going to do? Yeah. We're going to simplify, right? We're going to distribute the 99 over 16. We're going to add the 29 halves to the other side. So take just a second and do that and tell me what you get. Just a little bit of fun algebra with fractions this morning, right? Oh, no excuse on that. You don't need a calculator to do any of that.
Are we distributing the 99?
Sure. I'll start it for you. It's going to give you 99 over 16x. How's that? See how nice I am? Well, the 99 over 16 multiplied by 4 is just going to reduce the denominator, right? You're going to get 99 over 4. So you're going to have negative 99 over 4. And then you're going to have plus 29 over 2. But 29 over 2 would be what over 4? 58 over 4. And then you can add those two fractions together. So 99 over 16x, and it will be minus what? 41 over 4. So there's your equation of your line. What do you think? It's okay? All right.
Would you go back to the previous slide?
Yeah. Right here. All right.